Alright, now in this next video I'm going to show you a different way to do this that is more mathematically oriented than using if statements. We're going to take advantage of the fact that, as we saw over here, each of these digit positions is worth a value. The rightmost is worth 1, the second to the right is worth 2, third from the right is worth 4. So if we can figure out whether this position, if it has a 1 in it, then it's going to contribute whatever we get times the value of that place. Now in Scratch, the costume numbers, if we look at here at our binary, the digit 0 has a costume number of 1. The digit 1 has a costume number of 2. That means our costume numbers are all 1 higher than what they need to be if we're thinking about the digit. So if we get the costume number, we need to subtract 1 from it to get what the value of the digit is. So let's go back to our octal digit and our code, and we're going to disconnect all of that from our receive message so that we can write some new code. And now what we need to do is we're going to do some adding up. So we can use I'm going to make a local variable for this. I want the variable to be for this sprite only, and we're going to call it the digit total. Alright, and then I need a set statement. So I want my digit total to be equal to, and if I go and look at my first binary digit and I get the costume number of it, we know that costume number is 1 higher than the actual digit. So if I get a subtraction, take the costume number and subtract 1 from it, then that tells me what this digit is worth. More out of the way. Alright, now I want to add in what this digit's worth. So I'm going to go in and I want to say, alright, well, let's change my digit total by and I want to duplicate this and I want to change it to my next digit over, and I want the costume number. So if I get the costume number of binary digit 2 to the 1 power, that's this digit right here, 2 to the 1 power, subtract 1 from it, that'll tell me whether I have a 1 or a 0. But now this digit position is worth 2. So I need to take whatever I get from this and I need to multiply it times 2, because that digit position is worth 2. Let's add that into the total. And then now finally I can just duplicate that whole thing because I want to change my digit total by, and I want to go to my 2 to the 2 power digit. I still want the costume number. I still want to subtract 1 from the costume number so that I get the right value, but then this last digit is worth 4. So now if this is a 1, it'll contribute 1 to the total. If this is a 1, it'll contribute 2 to the total. If this is a 1, it'll contribute 4 to the total. So that'll give me a number between 0 and 7. So I can see up here where my variable appeared what my number is. So if I go ahead and start changing these, you can see having a 1 here made that a 1. Having a 1 here made that a 2. Having a 1 here made that a 4. And then of course if I start turning on, now I've got a 4 and a 2, which is 6. If I turn them all on, a 4, a 2, and a 1 makes a 7. So now in this variable I have a number between 0 and 7, but I know my costumes are numbered 1 through 8. So now I need to add 1 more to that number to make a costume number out of it. So I'm going to do this change again. I want to change it. I want to change my digit total by 1. Now this digit total variable in it has a number in it between 1 and 8, and I can go to my looks and I can say switch costume to, and instead of picking the costume by name, I can go to my variables and I can drop a variable into that spot. So now it's going to switch costume according to whatever number is in this digit total variable. So now if I start clicking on things, I can see if I make that a 1, my costume changes to a 1. If I have 2 1s, my costume changes to a 3. All 3 1s, my costume is a 7. A 0 in the middle is 5. A 1 at the beginning is a 4. And all off back to a 0. So now, very little amount of code, but using the mathematical properties of our number system helps us figure out which costume to turn on, doing it number based. And we really wouldn't have had to use as many blocks here as we did. We could have combined this and this and this with addition operators and just made it be one big expression. And if we were really a glutton for punishment, we could have put that one big expression right there. So this could have all been one really long block. But sometimes it's nicer to use smaller blocks just to divide it up and see what the steps are. Okay, so again, this same technique could be easily transferred to the other digits. Let's make this small. There's my other octal digit. If I take this, drop it on that guy, go to this guy. Well, actually let's go to my binary guys first. Okay, so let's drop him in that one. Let's drop it in that one. Let's drop it in that one. Alright, so if I go to here, we we need a new message. This time we're going to tell octal digit 1. Go to this one, pick octal digit 1, go to this one, pick octal digit 1, and now this is the nice thing when it's really small. There's not that much we have to change. We tell octal digit 1 that that's the message we want to apply to. Now, instead of doing binary digits 0, 1, and 2, we want to do binary digits 3, 4, and 5. And make sure we're still looking at the costume number for all of these. Digit total is a local variable, so it'll be local for this guy as well. And now make that big. And now this guy is changing. Seven. So now that one's changing as well. So once you get one digit working, it's easy to copy the blocks over to the other digits and get the other stuff working. And then this method is probably even easier to extend to doing your hexadecimal digits, because when you look at the math involved, you're doing the first one gets you 1, the next one is worth 2, the next one is worth 4. Well, to do a hex digit, you'll just include one more binary digit over, and that digit is worth 8. So you can get a 1, a 2, a 4, or an 8 into your total, and then based on that can change your hex digit. So it should be easy to transfer this method to using the hex as well.